Hello. Today we have these two equations and they look quite deceptively easy, but they're not. As you can see, the constraint is that the numbers x and y must be natural numbers, so like 1, 2, 3, 4, and 5, so just whole positive numbers that aren't zero. Well, never mind. They must be those types of numbers. Also, if you notice here, x and y both must be square numbers, so they must be numbers that are, let's say, 1, 4, 9, 25, and 36, and so on. This is because they're the squares of the natural numbers. As you can see right here. Okay, this is very important, as now we can write x as a squared and y as b squared. Substituting these values into our equations, we can get this. We can get these two equations right here. Rearranging this equation, you will get, rearranging it for b, you'll get that. Also, pick this equation because there's a small number and it's going to be easy to work with, okay? So since b is a natural whole number, and the only way to get a natural whole number from square rooting something is to have whatever inside the square root as a square number. So something, so 7 minus a equals something that's a square number, so something to the power of 2. However, a new constraint is very helpful because a must be smaller than 7, because if it's bigger than 7, it will result in the formation of a complex number, which is something we do not want. So these are the only possible choices for a. So 1, 2, 3, 4, 5, 6. Okay, so the only square number inside this set is 4. So b equals square root of 4, which equals 2. And in order for this to be able to be the case, a must have equaled 3. So now we have our two values, a equals 3 and b equals 2. Taking these two values here and going back to there, we can see that x equals 9 and y equals 4. Substituting these two values just to check back into the original equations, we can get 3 plus 4 equals 7. That checks for the first equation. And 2 plus 9 equals 11. That checks for the second equation. And that's how you solve the system of equations right here, given with this constraint. I think these equations were made by Ramanujan from the post I saw the other day. But yeah, pretty interesting. Have a great day.